So we have seen the 3 different steps in earlier videos. Now we'll be going through for the next step number 4, that is the calculation of effective depth. So step number 4, it is effective depth. We have calculated effective span, now effective depth. So effective depth, for that again we need to just refer clause 23.2.1, page number 37. So now if you just consider this clause 23.2.1, it says that the basic values of span to effective depth ratio for span up to 10 meter. So for simply supported beam it is 20, and that would be considering and then it is also given that in the step C, depending on the area and the stress of the steel for the tension reinforcement, the values in A or B shall be modified by multiplying with the modifying factor obtained as per figure number 4. Figure number 4 is in the next step. So for this we just need to consider percentage tension reinforcement. We have considered percentage tension reinforcement as 0.72. So for 0.72 and the value of Fs it is 0.58 Fy into area of cross section of reinforcement. Area of cross section of reinforcement, that is the required and which is provided. To depend upon that we have to consider this. So we will be considering one by one. So I'll just write down. So as per clause 23.2.1, page 37, let us consider this value as effective span by effective depth ratio, that is span divided by effective depth is equals to 20. Now we need to go ahead with the modification factor. So for modification factor, first of all we just need to calculate Fs, which is equals to 0.58 into Fy into AST required divided by AST provided. If we just consider this ratio as 1, so you will get it 0.58 multiplied by 415. Now if you solve, so you will get it around 240 Newton per mm square. So now if we just go ahead with this figure, so where actually it is given percentage of tension reinforcement, that is 0.72, so it has to be in this line, and Fs is 240. So it is going to cross it at this point. Now you need to just check what is the modification factor in this line. So this is 0.8, so it has to be 1, and it has to be in between that. If we just consider this, it has to be 1.1. So that's the modification factor. We need to just multiply it with the So therefore I can just write down here from figure number 4, page 38, modification factor is equals to 1.1, and therefore now we'll just multiply this span by effective depth. 20 multiplied by 1.1, so this is span by effective depth is equals to 20 into 1.1, which is equals to 22, and therefore now effective depth would be equals to this span, that is 8000 divided by this ratio 22. This is coming out to be 365 mm. So though it is coming out to be 365 mm, so for the safe consideration we can just increase it 400 mm or 450 mm. Let us increase it as 450 mm and we can write down, so therefore considering effective depth as 450 mm and assume cover equals to 50 mm, 50 mm. So therefore in that case you will get total depth which is equals to, this is 450 mm plus 50 mm, that is going out to be 500 mm. So that's it, we got the total depth of 500 mm.